So this is video 11 and we're going to deal with photovoltaics. So see here in the examples projects folder, we've got a typical job that's been set up. And here we can see a prescribed project we've already done. So effectively what's happened here is that using these symbol libraries, using the PV array, you can place it on the layout, and then what you can do is once you've placed it on the layout, you can go in and put a postcode in, or you can put a latitude and a longitude location in. So if you're hooked online, you can then do a search and that will find your location with a latitude and longitude. What it does, it uses the NASA GIS dataset of over 260 locations in the UK to give you your horizontal irradiance values. And then what you can do is use minimum or maximum values. You can tilt the panels to latitude to get the maximum performance out of those panels. And then when you go to the PV sizing tab, if you're servicing a daily load of 70 kilowatt hours, what you can do is put in a series of panels from this list. So there's a database of panels which you can add to and take away from. So for example, if I was to delete a panel, I can always then reinstate with another panel. And then what you can then do is, I'll delete that one, delete that one, delete that one. And then you can see here the array available kilowatt hour load we're trying to service given the daily kilowatt hour load available. So in putting these panels in, so for example, if I was to remove this 290 and put in a 235 and add that panel in, you can see I've got a bit of a shortfall there. So the idea is to get your panels to at least meet the requirement to make sure that you can meet that demand. What you then do is put your other inverters, put your other solar panels in, and then what you can do is put an inverter in, and then what you can do is put the cost of electricity per kilowatt hour. So for example, typical electricity is these days about 14-15p a kilowatt hour. You can run a calculation and that'll give you your cost savings per year based on the costing. So the idea is when you set these solar arrays up originally, you will have the panel names in here and you put them over to the right hand side to associate them with the inverter. So these two panels here are these two here associated with this inverter. There's a whole load of weighting values as well here which will affect the performance of the panel. So for example, the age of the panels, 1 represents a brand new panel. If I was to put 0.9 in there, that's the weighting factor for a panel that's 11 years old. So if I was to run the calculation again, at the moment a brand new panel puts out £796 of annual energy savings. If I calculate that, that then reduces to 649. And also you've got the soiling of the panels, the shading of the panels, etc. So all of the weighting factors are included in here. And also whether the AC or the DC is electrically separate or not. If they are separate, then you don't need a special device. If they're not separate and they're enclosed in the same box, then there is a requirement and it does a test to make sure that you've got a BSEN 62423 device protecting that inverter. So all the caveats from the regulations surrounding the panels are built into the calculation. And then you can see the rest of the project here set up as we've been looking at previously with, in this case, a horizontal bus bar. That could actually be represented by a distribution board. Instead of having 4 tap-offs, you could have represented that with a distribution board. So the photovoltaics are there so that you can run the calculations. So when I then run the display calculator, or any problems that are found on the circuits can be highlighted. So we can go into results and find out what the problem is. And it's saying that the string voltage exceeds the DC voltage rating of the fuse of that particular device. So you can see we've got an issue there, and it's probably the same with these as well. So any issues that arise are highlighted. So that's a quick overview of the photovoltaics and how you'd set them up.